We're live. All right, welcome everybody to House Energy and Digital Infrastructure. It's Friday, April 3rd, and we are here starting to kind of approach the finish line on the testimony we're taking on S202, which is a bill about portable solar or plug-in solar devices. So I'm Representative Kathleen James from Manchester.
Scott Campbell from St. Johnsbury.
Richard Bailey from LaMoille 2.
Michael Southworth, Caledonia 2.
Christopher Howland, Rutland 4.
Dara Torrey, Washington 2.
Great. We've got a few members who will probably show up in a minute. And Rep Morrow, do you want to introduce yourself?
Chris Morrow, Wyndham, Windsor, Bennington.
Awesome. And we have some guests.
Representative Brady here from Williston, and I've got 5 students from Colchester High School here today that are observing the process.
Excellent. Well, for just so you guys know, so we've been taking testimony on plug-in solar, which are basically like, it's called balcony solar, and they're smaller solar devices that you can just plug into a wall outlet. And right now, those devices are kind of commercially available. You could order one off YouTube. Not YouTube. You could order one off Amazon and plug it right into your house to generate a little bit of solar power. And we're taking testimony on a bill that would make sure that Vermont has safety standards in place so that if you buy one of those, it's safe to use. And so that's going to be what you're going to hear us talking about today. There's a national group called Underwriters Laboratories that certifies all kinds of appliances to make sure they're safe. And so we're going to make sure that UL certification applies to these devices. So you're going to hear us get pretty wonky, I think, yeah, with UL 3700. So, Bill, thanks again for being flexible. And if you could just introduce yourself for the record.
Sure. Thanks. Appreciate the opportunity, members of the committee and chair. Bill Brooks Engineering is my company. A registered professional engineer. Both as an electrical engineer and as a mechanical engineer. I have a master's of science in mechanical engineering from North Carolina State University. And I've been working in this field my entire careers for 38 years. And one of the few engineers on the planet that have that many years in this field. And have worked on pretty much every code and standard that relates to solar energy systems in the United States and internationally. So codes and standards is kind of my forte. And so that these issues as they come up are something that I generally pay attention to and have as much or more background than anyone in the United States on these subjects. And so there are plenty of questions about this particular area of plug-in PV, PIPV, if you will. And those issues are rather straightforward. Sorry. And so that's one of the reasons we do have product safety standards. And there are numerous product safety standards in the solar space. And this new product safety standard is specific to address the issues related to this particular application of what we call photovoltaics, which is a fancy way of saying solar electric power. So I've been on the National Electrical Code making panel 4 since 2009. Have chaired most of the committees related to photovoltaics over the years, from issues as small as plug-in systems, which are extremely small. And I also chaired the committee that oversaw the large-scale photovoltaic electric supply station article of the National Electrical Code, which covers the largest systems in the world, which can cover 10-mile by 10-mile systems with millions of solar panels And so, obviously, photovoltaics can scale from a small device on your watch to millions of solar panels providing major power for cities and communities.
Great. We have two members in particular. Yep. Reps Campbell and Southworth, who've been putting together a list of specific questions we have about 3700. I'd say most or all of them along the lines of, does 3700 already include this, or do we need to be specific about it in the bill? So, Scott, do you want to
Sure.
start? Okay.
Sure. Yeah, so we have heard some concerns about safety issues, and obviously that's what we want to be absolutely sure that we're doing correctly in this bill. And we have also referenced the Virginia bill that just passed earlier in March as a good starting point. So one of the things that we're curious about is that there's a lot of reference to the new UL standard 3700, and what does that include? We haven't actually seen the standard. We're hoping to maybe get a look at it, or ask somebody like you or somebody at UL whether it includes these things. So a reference to the UL 1741 standard. Is that also include? So are you familiar with 3700? I guess is the first question.
Yeah, sure. Great question. And let's start off at that level. I would classify UL 3700 as a type of standard that's an umbrella standard. That term that I use, which I pretty much coined as an umbrella standard, it covers basically a variety of standards that come under what you'd have to cover all the safety issues related to a plug-in device. And so among those, so I don't know whether you've read the UL white paper that came out about 2 days before the 3700 standard was published, but the UL white paper basically is an excellent kind of rundown of all the things that the UL standard has to address in order to be a fully valid safety standard. And although since it predated the standard, it doesn't specifically have a lot of references to 3700 because it wasn't there yet. A good way to read that white paper is to say, here's all the things that we're going to cover in 3700, and here's 3700. And
That
so
actually is, that's helpful.
Yeah.
Yeah, but on you go.
Well, and that
so UL 1741, we throw around these numbers, and I apologize. You sound like when you say that number that you actually know what it means, and probably most of the other people in the room don't. But
well, I don't know what it means. I mean,
okay.
I know that it had to do with actually not plug-in PV, but just PV that's installed, permanently, and then how it interacts with the grid.
Right.
That's all I know about it.
So it's the broad standard. It's actually 1741 is a very broad standard. It's been around since 1999. I'm on the technical committee for 1741 and was involved with writing it. And it covers a whole range of issues related to the electronics and the electrical equipment that coincides with making the solar panels run safely and operate. And it includes a whole section on what we call a utility interconnection. Okay, so connecting, certainly one of the biggest issues in my career since day one has been how do we get utilities to allow these products to connect to the utility grid. Okay. And so the utility grid heretofore you would have to have all kinds of very specialized electronics and switchgear and things like that, because things that connected to the grid were measured in millions of watts, not tens of watts or hundreds or thousands of watts, millions of watts. And so all that infrastructure that you needed for interconnection was valid for very large systems, but when you got down to a residential size system, and certainly a small residential size system, they were prohibitively expensive. And so a lot of technology went into how do you make these products able to connect and parallel with the utility company in a safe way so that when the utility goes down, they automatically shut down. So it's something we call anti-islanding. And we actually invented technologies in anti-islanding, which are now fully accepted today as they work. Nobody has concerns about them. They do what they do. Nobody's gotten hurt from these products. Oh, I'm sorry, I was bored. I was hoping to keep the attention of those high school students, and I just failed miserably. I'm so sorry.
Fighting Bill.
Anyway, oh well. I was hoping to get a few people on the team for solar energy, but I guess not. Hopefully I'll make an impression, but no. So that's what the standard, that is what one of the things that UL 1741 does. And it's an absolutely integral part of 3700. There's just no way that you could plug anything into an outlet that was eventually connected to the utility company that didn't have all these safeties in it.
So we don't need to reference 1741 and statute, because that's part of it. As long as we reference 3700, we're good.
That's right. That's why I say it's an umbrella standard that covers all the issues that come up, of which there are numerous, and certainly utility interconnection is one of them.
Okay.
Okay.
Sure. Go ahead.
So I know we have the white paper. I've read it a couple of times. Is there an actual just UL 3700 standard that has been written that we would be able to get from you?
Well, I mean, you can't get it from me because I have a copy of the standard, but it's a copyrighted document that I'm not allowed to share. It is available online. You can actually reference it online. There's an online portal, and I'm sure it sounds like you're going to be talking with UL. Who at UL are you going to be speaking with?
Megan, and then
Who was it that we talked to?
Megan Housewright is a government affairs person, and she brought
Okay.
or is bringing someone more technical.
Okay. Might be Pete Jackson or could be Steve Jones. Those are two people in their UL Solutions group. I'm sure they could share one with you. You know, again, there's sensitivity about sharing documents that are, commercial documents. And so that's the only reason I don't hesitate. If I could do it, I'd give it to you right now. So
The standard has actually been written in standard form and not just a white paper, correct?
Oh, absolutely. Absolutely. Yeah. It's called an outline of investigation. And many people have misconstrued that to believe that it's an outline of investigation is not a standard. It is a standard. There are many outline investigations out there. And so it's the first version. It's basically UL is tasked by OSHA and the federal government to write standards for the solar industry. So all standards in the United States that relate to solar are written by UL. Okay, so they have essentially a mandate to write these standards. And so if there's a need for a standard, they'll often they will internally work on a standard. They'll often bring in outside folks like myself and other folks to help maybe provide a little bit of input to that outline of investigation standard. And then they release the standard onto the market, and then products can be certified to that standard. That standard became available on December 11th, 2025. That's when it was published. And then that standard goes through a life of its own, which goes through revision processes. So that standard we just mentioned, UL 1741, of which this standard is part of that family. So the 1741 family has 3741, 4741, it's got 9741, it's got a whole family of standards, and 3700, which shares a 7, is part of that family. But anyway, so 1741, which was published as an outline of investigation in 1999, is now on its 15th revision, something like that, over the years where we've revised it. So 3700 is available. Products can be certified to that standard. To my knowledge, and again, my knowledge is not perfect, there are no products currently certified to that standard. There may be some in process. UL, because of their agreements with their clients, is not at liberty to disclose, who or what or whether they're working with customers and things like that. But the standard exists, and that is fundamentally important because these policy decisions that you guys are looking at are hinged on the reality of the standard existing.
So how long is the process for sort of certifying a product or a device?
Oh, anywhere from a month to 6 months.
Okay, so there are some products that are currently in the process now.
I've been led to believe through obscure references that there may be products available, but it's like one of those things where we can't confirm or deny that there are products available.
All right. Well, some other specifics that we wanted to be sure were referenced, and they were mentioned in the white paper. We did get the white paper, and I think probably all of us read it. Is there a requirement for a dedicated circuit? Is there a requirement for a specialized plug? Is there a requirement for a bidirectional GFCI? Do you know, are those actually specifically referenced or required by 3700?
Well, so there's 3 very different questions. And I'm interested in the term dedicated circuit, which in the National Electrical Code is called an individual branch circuit, is not a requirement of the standard, nor is it a requirement to be safe. So I heard that statement, and I'm curious where it comes from, because there is a technology, and the real technology that makes this PIPV technology practical is called power control systems. Okay, power control systems, which is also part of the family of 1741 standards, it's 3141, is part of 3700, under the umbrella of 3700. And what power control systems do is, and I actually invented the term, and it went into the 2020 National Electrical Code, so it is part of the code, your code in the state of Vermont. And what it does is it provides monitoring and control of sources and loads to maintain current within the capability of the wiring systems that we're talking about. And so there is a lot of technology that goes into that. It's become an amazing technology. I mean, we invented it as a means of addressing concerns of mixing sources, which a solar system is a source, and loads together, because that's a complex thing. And we can't just rely on the simple methodologies of circuit breakers that we have today to address that issue. So power control systems are really the key to preventing damage to circuits on a branch circuit or other circuits and a switchgear or panel boards in a house or a building. So understanding a little bit about power control systems is critical to this entire conversation. And without that, people would come up with the idea, well, you'd have to have a dedicated circuit or things like that, which if you didn't have power control systems might be a logical answer. And then we have this issue of bidirectionality of GFCIs. So we've been talking about GFCIs for a very long time as they relate to trying to push power into a circuit and how that might affect the circuit. And years ago, we found issues with certain types of GFCIs where they could get damaged under certain conditions with the products that were around 25 years ago. What has not been done recently is a detailed study of existing products and existing, products that are in people's homes and the existing devices that would be used in PIPV systems to see how compatible those things are. So we have devices that are in your house that are circuit breakers that have GFCI capability. We have receptacles that are GFCI devices, and those are part of the testing of 3700. So if somebody comes up with a product, they're going to have to prove that they can be installed and plugged into any device that's on the market today without damaging it. Typically, these devices haven't been tested for bidirectionality, but they could be tested as part of 3700. Also, it's likely that the device itself will have its own GFCI bidirectional capability for additional protection. And so it's not unlike we're familiar with RVs and various power cords that are used for construction that have GFCIs built into them. And so you can build a GFCI into a pluggable device and things like that. So these are all issues that have to be dealt with. So it's not that they're going to be poo-pooed or pushed to the side. They're front and center. They're well-known issues. We've been talking about those issues for literally 25 years. And so they're not surprises. They're not like, ooh, here's a new thing. They're well understood and well known. And there was another issue. You had 3 issues. What was the third issue? I missed it.
Let's see, a specialized plug in terms of
Specialized plug. Yes. So the current version of 3700 does require a specialized plug. Okay. But that is not necessarily a requirement of having a safe PIPV system. It is a requirement of the current 3700. But it's extremely likely, and if because I will be involved, I will certainly be working toward doing the testing and requirements related to allowing a standard 3-prong NEMA 15 amp plug to be used safely, because it's all about touch safety. Okay. And just as an example, and this may become part of the standard, may not. Every pluggable UPS, uninterruptible power supply that are used for computers, every single one on the market today is tested to a standard, and that standard, if you were to inadvertently disconnect a UPS from the wall, from your wall outlet in your office, that plug can remain energized for up to 1 second. Okay, so there is fundamentally actually no difference whatsoever between a pluggable UPS, of which there are millions in the United States, and everybody's not concerned about the safety of those devices, and we don't hear about people getting shocked from plugs from UPSs. It just doesn't happen. And so that standard's been successful. But those devices do remain energized in the exact same way that a device like this could remain energized. And whether it's 1 second, whatever the rules are, again, that has not been determined yet in the standard right now. To be exceedingly, I would say, safety conscious. The first version of 3700 said, well, we're not going to cross that bridge yet. We're going to require a specialized plug, and that specialized plug would require that the unit be shut down before you would remove it, and would be specialized so you couldn't interchange it. And that's certainly a great way to start. And that kind of sets the stage for the kind of issues that you have to address moving forward so that people don't get shocked.
Okay, I have one follow-up, and then I know there are questions, and my follow-up is back to your power control systems. It sounds like that deals with any overcurrent problem that we heard various presentations about. Is that accurate?
Yes, power control systems absolutely deal with overcurrent.
Okay,
That's
And that's
the entire reason for it.
right. So even though we heard presentations and little graphics and all that about how a solar panel can sort of bypass the circuit breaker and put more amperage into a wire than it's rated to carry. We shouldn't worry about that. It's covered by UL 3700.
That is correct, and it's kind of I guess fun to hear when people use the term circuit breaker masking. You might hear that term.
Yes,
I invented that term, so it's kind of fun to hear people use terms that I've invented, and because the rules related to how we interconnect permanently wired systems into houses have to deal with the same exact issue. Okay, so we have to make sure, and those are generally going on what we would call a dedicated circuit, and so. But at the same time, we can interject. So here's a comparison. What's completely allowed today in the National Electrical Code and your electrical code is that we can interject a photovoltaic system into what's called a feeder. A feeder in a house is coming off a circuit breaker in your main panel going to a sub panel. So that's called a feeder. And so we can actually interject power into that circuit. And then we have to worry about breaker masking for the feeder breaker that's protecting that conductor. And so the code says, and I wrote this in the code, it was my design, for the connection that is downstream away from the electrical panel toward the sub panel, you have to reestablish overcurrent protection for the downstream conductors because you have two sources now, right? You have the main source coming in from the feeder breaker, and then you have the solar coming in from here into that, and the streams combine and they go to this sub panel. So you have to then protect the wire with an overcurrent device at the load side of that connection point, and that protects everything downstream. Okay, so that's in the code for feeders, and so that's the same. And also another way to do that is not necessarily an overcurrent device, but power control system. So the power control system monitors the current coming from the feeder breaker, the current coming from the solar. And if the current coming from the feeder breaker and the solar adds up to more than the rating of the conductor, it just backs the solar off. Okay, so the passive feeder breaker still is allowed to do its job. So these are the things that are done on a feeder level and can easily be done on a branch circuit level as well.
Okay, I know Madam Chair had a question also, and then Rep. Southworth as well.
No, I'm gonna turn it over to Rep. Southworth.
So I just kind of want to bring this down to a little bit easier level to understand for me, for us.
What?
Um,
I'm very disappointed.
You're saying the power control system is built into the PIPV, correct?
Yes, I believe that as products come onto the market, they're all going to have some type of power control system capability in them.
And that is a requirement under UL 3700.
It's a requirement under the National Electrical Code. So when UL writes a standard, they write standards that are commensurate with and compatible with the National Electrical Code. So with the code that we have today, the only way to truly comply with the code in anything other than a dedicated circuit. So we heard that term earlier. We could use a dedicated circuit and comply with the code. But how many people have a 15 amp dedicated circuit in their house? The answer is not very many. In order to connect to what we call a general purpose branch circuit, which can include multiple receptacles and lighting and things like that, we have to have power control.
Okay. So along with that, if this power control system is built into the PIPV, it is plugged into a branch circuit, theoretically it is supposed to, and this is where I get caught up. Is it going to sense the amount of load before it allows the power to go in from the panel into the branch circuit?
Yes.
Okay.
Absolutely. So one way to do this, and again, I'm an innovator. I don't have any patents because I litigate patent cases and I know how hard it is to hold a patent. But I help companies that work on patentable things. And one thing you could do is you could actually develop an outlet or a receptacle, we call it in the code as a receptacle. We could develop a receptacle that has all the power control system sensing devices inside it, maybe even an overcurrent device inside of it. Okay. And we could pull out a GFCI that maybe didn't have the proper ratings or whatever. We could pull that out and we could install this device, and it could sense all the load going downstream of it away from the panel, so that the current on the branch circuit going down to it, where we have these two streams that I just talked about, two streams of power coming together, can never provide enough current to overcurrent the downstream conductor. So that's an example. Now, of course, that would require removing a receptacle, and that may not be necessary in all cases. So you may come up with a technology that actually is able to do this remotely through the device. Again, we're going to see some really cool innovation out of this whole thing. And one of the reasons that we developed this power control systems idea was just to see where human innovation would go in this area. And it's really been mind-blowing to see how technology and manufacturers have come together with the safety standard to develop some really, really amazing products that nobody ever thought of before. So yeah, that's one example of how you could do that.
So without a power control system, there is still a chance of an overcurrent occurring, correct?
Well, if you exceed the ratings of the conductors, it is possible. So one of the things that we're looking to so I've written what's called a public input or a proposal for the 2029 National Electrical Code, which would allow for small systems of around 350 to 400 watts to be plugged into one branch circuit on one general purpose branch circuit on per house, only one. And we can show that about in that 350 to 400 watt range, it is physically impossible to overcurrent the downstream conductors, which is what we're worried about. And the reason for that, I don't want to go into all the details, but it has to do with all the methodologies we use to connect to feeders and things like that. But the main breaker has to be derated for how much current it's allowed to run through it to 80% of its rating. So a 15 amp breaker can handle 12 amps continuous. So we can interject another 3 amps into that same conductor for downstream conductors. And the conductor itself is rated for 15 amps. And it is physically impossible to overcurrent that conductor at 3 amps. Okay. Anything higher than that, and again, this is going to get deliberated in the NEC process, and I'll be representing that. Anything that goes higher than that, we go to PCS. So that's something that's going to be kind of a foundational thing. You can plug one of these things in. You can't plug more than one of these things in. Anything more than that's going to be PCS.
Which would be 1,200 watt panels.
It could go up to 1,200 watts, which is actually pretty large. I don't know whether you know how big a solar panel is, but a 400 watt solar panel is approximately a little over 3 feet by 5 feet. Okay, so that's a pretty big panel. And so you'd have to have 3 of those to make 1,200 watts. And that's, I believe, that's the threshold that's in the Vermont bill?
Yes.
Yeah.
Okay. And so, but if you had a 1,200 watt system, unless it was on a dedicated circuit, as pointed out earlier, you would have to have PCS to make this work. There's just no other way to do it.
Great, thank you.
Okay, you mentioned the National Electric Code, and so what I took from what you said was UL standards. They don't need to reference the National Electric Code because UL standards must comply with NEC.
That's correct. That's correct. It's kind of a general rule because these products are interfacing with the electrical code in one shape or another. It would be foolhardy for them to develop a standard that was in conflict with the NEC, and so they're usually pretty conservative, if you will, in their interpretations of the code and what they would allow to go through a product safety standard. Sure.
And how about IEEE 1547? There was another standard that was mentioned along the way. Is that also covered by 3700?
Yes, IEEE 1547. But I should change their name to IAAA. That sounds better to me. IEEE 1547 is basically the IEEE standard that UL 1741 uses as the interconnection requirements. And so I helped develop the rules that went into IEEE 1547, which are all the specific interconnection limits and frequency and voltage limits, anti-islanding, all that's in 1547. And then document 1547.1 is a test standard. And then UL 1741 adopts 1547.1 and associated grid support stuff. So we have supplement A and supplement B that go along with that are part of 1741 that are addressing the specific issues in IEEE 1547.
Okay. Okay. So I think what it sounds like is that what we need to cover in terms of safety for Vermont residents, if they're going to buy these things, is that they comply with UL 3700 if they're larger than, 391 watts. Otherwise, they don't need to comply. Is that true?
No. So no, that's not correct. So just a fine point on that. The 391 number, which I put together as a commensurate number to the 800 watt German number, which is what they use in Germany. It's just translating that number to US voltages and currents. That is that threshold that I was talking about, under which you do not have to have power control system.
Right.
That's all. Everything else about the standard is critical. So utility connection, critical. Touch safety, critical. Bidirectionality, GFCI, critical. So these are all things that have to be tested and approved in the 3700 standard. Size can be like, okay, you can have a system. For instance, here's an example of how it might go. And again, this is all just kind of dreaming about the future, which I like to do. You have a 360 watt panel or something like that, something under 391. it's got PCS built into it, but it doesn't have any PCS hardware to interact with so you plug that in and it works. Okay, fine. But what it's doing is it's sending out a pulse, and we do things called power line carrier. And so it sends out a pulse and says, is anybody else out there? And if nobody responds and nobody else is out there, he says, oh, okay, I can run because nobody else exists. I'm the only one here. And then they go, this is really cool. I'm going to go buy another one. So they go in and they plug it in to their house, and it does the same thing. It goes, is anybody out there? And it goes, yup, I'm over here. And they go, well, wait a minute. I can't run with you unless I have a concert master called the power control system that says that it's okay for both of us to run. Okay. So now that goes, well, wait a minute, where's my concert master? And so then they install a concert master and they go, oh, okay, now I know where I am at. I know that I'm not going to overcurrent anything. And so now I can operate. And so then I can plug in another one and another one up to 1200 watts. And so
Is that concert master integral to each of these panels that passes UL 3700?
if it was a product that was designed to be installed in more than one, yeah, that's where I believe this is my interpretation of the future. The initial products that are going to come on the market, I believe, will all have power control systems and all require a power control system to function whatsoever. So unless they have a concert master, they're not going to run. Okay. And so the question is, would there be, because of the things we're deliberating about in the NEC and will eventually deliberate on in 3700, would there be a time where we could actually plug a device directly in and it not have to look for a concert master? And so I don't believe that that's currently possible in the 3700 unless, well, there's another thing about 3700 that we need to talk about. And that is, with all UL standards, when you buy a product, it has installation instructions. And those installation instructions are required to be followed by the consumer or the installer, whoever's using the device. And if you violate those installation instructions, then all bets are off on the safety and operation of the product, because that's not how it's certified. And so these are stipulations. And so it could say what kind of outlet you can plug it into, whether it would have to be a dedicated outlet or not. And the type and size of the outlet, all that kind of thing. And it's similar to, I use the analogy of a hair dryer, a blow dryer in your bathroom. So any outlet in your bathroom for a house that was built after 1968, something like that, has to have a GFCI outlet in it within 6 feet of a sink. Okay, so your house is going to have a GFCI outlet, and so if you go out and buy one of the original blow dryers, it's going to tell you in the instructions you must plug this into a GFCI outlet. Can't use it any other way. That way, this idea of how to murder somebody where you plug in your hair dryer and throw it in the tub can't happen, because the GFCI outlet's going to trip. So it foils the murderer with the hair dryer. So yeah, well, so it turns out we have houses that were built before 1965, and you have plenty of them in Vermont, right? So most hair dryers, in fact, all hair dryers that are on the market today, have a GFCI device built directly into it, right? It's got the little plug and it's got a little red button and a little yellow button on it. And that's the GFCI. So foiled again, I'm in an old house and I still can't murder this person with the hair dryer. So, and so the safety standard is acknowledging the existing wiring of the house and building a product that's safe for interacting with that house. And that's the same thing, essentially, that we're dealing with here with these plug-in devices.
Okay, I have one last question about UL standards. Does the 3700 have any reference or any requirements about mounting? these things so that they don't blow around in the wind.
Yes. Yes. So again, back to the installation instructions. A lot of people have thrown around the term balcony solar. I don't like the term personally because, balconies are not as common in the United States as they are in Europe with a lot of high rise, living, but we certainly have it. Absolutely. And so if you were, for instance, wanting to set this out on your lanai, I like that term better than balcony. It's Hawaiian.
Yeah.
If you're going to put this out on your balcony, then if it were a fully portable unit, you say, well, you can set it out there and bring it back in, set it out there, bring it back in, do whatever we want. If you want to put it in permanently, well, then here's all the rules. If the product is allowed to be mounted permanently, okay, here's all the rules that you'd have to follow in order to mount it permanently. And so we have mounting structure standards. It's UL 2703, which is also called up by 3700, that says if you're going to use mounting hardware to mount this device, then you have to follow these test standards, and these structural concerns have to be addressed, and they have to be in the installation instructions that tell people how to do that correctly. If you're not going to, you can tell people, you cannot permanently mount this device. It could be something that you just, it's on wheels and you wheel it outside during the day and you bring it in at night or whatever, or, it's designed to be put in your backyard and there's a device that fastens it to the ground, or maybe a screw anchor that holds it in and keeps it steady. Whatever is intended to hold that device in place would have to be in the installation instructions, and the customer would have to follow that. Now,
Okay.
if somebody just buys one and just hangs it off the side of their balcony, it'd be not unlike somebody putting a 20 or 50-pound flower pot on the corner of their balcony railing, and whoopsie, it falls off and kills somebody 10 stories down. You don't, that's irresponsible for the person to put the flower pot there in the first place. It's against regulations. Nobody's allowed to do that. And somebody did it. So can people break rules?
Well, yeah, I mean, I guess the question is, are there requirements about in 3700 about how you deploy these things? Can you just prop it up against the side of the house with no mounting at all? Is that allowed? Is it in
Well, it would depend on what kind of product it was. So there are plenty of portable solar panels that you just actually unfold. I've got one. It unfolds like, an accordion, and it weighs 5 pounds, and you can lay it on the ground. You take it camping with you, whatever. It doesn't require permanent installation. And then when you're done with it for the day, you fold it up and you bring it back in. So there's nothing wrong with having a product like that. And if that's how it's intended to be used, that's fine. But if you were to take it to the step of telling people that, so the installation instructions are going to confine the methodologies in which it can be used. Okay.
Yeah.
And so if somebody goes beyond that, then that's their liability. It's not on the product manufacturer's head that somebody did something crazy. It's like, you remember hearing the stories about people picking up a push mower and trimming their hedges with it, and somehow they got hurt. How could that happen? It's like, so they had to put in the installation instructions, no lie. If you look in the installation instructions for a lawnmower, a push mower, it will tell you not to pick that thing up and use it as a hedge trimmer, because somebody needed to hear that. And so that's the kind of things from a product liability you have to put in to say, hey, listen, we haven't designed our system to mount to a balcony, and we don't want the liability of somebody mounting this to a balcony and hurting somebody. Okay, well, that is a decision by the manufacturer to omit that particular installation technique for liability purposes.
Okay, great.
Bill,
Well, thank you.
Oh, yeah, Rep Southworth? No, please. ahead.
I just have one question, and I don't know the answer, so I'm asking you. In our bill, it says systems complies with UL solutions or an equivalent certification by an equivalent nationally recognized testing laboratory. My question is, will they have to create their own standard at that point, or will they utilize UL 3700?
Yeah, I kind of see that language as kind of redundant and somewhat unnecessary, but like I said, UL has been tasked by the federal government to write standards in this particular area. So it doesn't mean that a Met Labs, which also is a nationally recognized testing laboratory, or Intertech couldn't write their own standard. The challenge would be what makes their standard better, different, whatever, than the UL standard. And so, generally the way it's worked for my entire career is that UL writes the standard and people certify to that standard. So even though it's it's an outline investigation, it's published. Intertech or CSA or Met Labs, which are all allowed to test to UL standards, could certify a product, but they're going to choose to use the 3700 standard. There is a certain amount of liability involved with writing your own standard. And that's why UL is very, I would say, safety conscious in their initial offering of a standard, so that it doesn't, it's obvious that it addresses the safety issues. And then what they do is they put it out to the stakeholders in the community. And we have an ANSI process, American National Standards Institute process, that brings together various parties distributed evenly over a variety of stakeholders. And we take that standard and we work on it and we revise it with and vote on any changes we would make to that standard over time. And as I said, we get additions over time. And so that's the way standards live. So they normally start out kind of conservative, if you will, and very, very tight in their safety requirements. And then as we understand more about it, it's not that we're loosening safety, we're just allowing more options to be safe within that confine. And so I have not found that CSA, Intertech, or Met Labs have ever decided to go off on their own and make their own standard. It just doesn't work that way. They don't do it. And they rely on the UL standards. There's a lot of effort and work that goes into it. That's another reason they don't do it, because it takes a lot of resources in order to write a standard. And then once we get into this larger community standard and then turn it into an ANSI standard, then that has, they're both standards, but now it has been reviewed by a much broader group of folks and usually has some more options for application.
I think the reason why that or equivalent language is included is because we don't like to reference one particular company in statute.
That's right. And in this particular case, it's and it's fine, by the way. I have no problem with it. It's because the federal government has kind of tasked UL with this, it is kind of a territory issue. But to that statement, it does not, that federal mandate or whatever to UL does not prevent other people. So I think there's nothing wrong with the language. And really where it came from, I believe, was the Utah legislation, which predated 37 by quite a lot. Right. And so there was a concern that if UL doesn't come forward with a standard, then Intertech could write their own standard. And they are OSHA approved, nationally recognized testing laboratory, and they could fit the bill too. But now that we have 3700, it's a bit of a moot point.
I was just trying to see if we would be having to look for another version of UL 3700. But thank you.
Bill, thanks so much for joining us. I just, we'll let you go, but I just wanted to try to briefly, I just want to make sure I was listening and taking notes. And I'm just gonna, and it can be a brief answer. I just gonna go back over a list of things we had from all the testimony we've taken. There was a list of things that different people told us, oh, you gotta put this in the bill. And what I heard today was that all these things are covered in one way or the other by 3700. So I just want to recap what I think I heard is that a requirement for a dedicated circuit, a requirement for a specialized plug to satisfy touch safety, a requirement for bidirectional GFCI, and a specific mention of UL 1741, a specific mention of IEEE 1547, a reference to the NEC, and mounting requirements are all covered by requiring compliance to UL 3700.
That's correct. The issues that are behind all those concerns are covered in
Yes.
3700. So, and that's why you do not want to have those details in a legislative bill. And just as an example of that laundry list that you just mentioned, if you were to put in your bill that it required a dedicated circuit, okay, then that would fundamentally hamstring the technology in a way that was inappropriate because we have power control systems. And so because of power control systems, requiring a dedicated circuit is completely unnecessary. Okay, so that's why it's important not to have those kind of languages in bills, because it's you rely on the safety standard. And in this case, sometimes when Utah wrote their bill, there wasn't the standard for them to look at, but now we have one. It's in writing, and so it's not a question of whether or not the standard might address these issues, and we have to worry about them, and because they don't know what they're doing, it's in there. And so that's something that, one of the benefits of not being the first on the block is being able to take advantage of what's already been done.
That is so helpful. I think we have two more quick questions.
Bill, you mentioned the 80% load factor on a breaker being rated for 15 amps continuous current. And then you mentioned the power supply, backup power supply for the computer. Did you say it can remain in touch potential for a minute, or did you say 60 seconds?
1 second.
1 second.
1 second.
60 cycles.
That's correct.
Okay.
And so if you can pull it out of the wall and touch it to your tongue in less than a second, you might get shocks.
Okay. All right. So continuous current and a time current curve, where's that continuous current? Is it out at a second, or is it out longer than that for a 15 amp?
3
break?
hours. The term
3 hours.
continuous
Okay.
in the National Electrical Code is 3 hours.
Great. Thank you.
Okay, and I just wanted to also echo what I think I heard, which is that the fact that we have old housing stock in Vermont and some electrical wiring might not be modern, that doesn't require anything in our legislation beyond the UL 37.
That's correct. And so, for instance, and that's where the National Electrical Code comes in, because every house has been built according to whatever code was available at the time. And so when we look at applying the code to something that goes back in history, like any directly connected, permanently wired photovoltaic system, we have to do the same thing, right? So we have to address all those issues. It doesn't matter how old the house is. Okay. And so a house that predates GFCIs, for instance, actually is a simpler case for us, because we can have our own GFCI on our device and we don't have to worry about interfacing with somebody's GFCI. The most complicated is going to be older GFCIs and making sure that anything we do is compatible with those older GFCIs, or there may be a requirement that says, well, these specific older GFCIs, they would have to be removed. You'd have to replace them. The good news about GFCIs is they don't last all that long. And so it's a pretty common thing for GFCIs to fail and need to be replaced. And when they fail, if you're familiar with this, if you ever had one fail on you, and I've had many over the years, they don't work. They just don't work. You push the button and it just doesn't work. And it's like, darn it, I got to go get another GFCI.
Great. And the other reason to not have the items spelled out separately is that the standard evolves over time.
That's
So
right.
you reference it once in the statute and let it evolve the way it's going to, and not have some
Exactly.
pieces.
Exactly. And it's going to become more and more robust over time. Again, the start out is a pretty confined set of requirements that says, here's, you got to do this. And then it goes, oh, well, we've done all this testing. We've done all this research. We now know that you can go to here. And then now we can go to here. And then now we can, so now you have a product that says, hey, you can plug as many of these things into your house as you want. It's fine. But when you hit 1200 watts, they don't work anymore. So it's like, have on at it, whatever the situation is. So, I mean, could somebody take a power strip and plug a whole bunch of plugging devices into it? The answer is absolutely. And will they? I'm sure they will. And so, but there's all kinds of things that we can do to our house that attempt to kill us. And so that's why we have instructions, and that's why we have, rules, and we have regulations and things like that. And at the end of the day, we cannot prevent somebody from a Darwin Award. Those get handed out on routine basis.
Great.
Thank you so much.
Thank you for your time. That was really, really helpful. Yeah, we did need that. All right. Thank you, Bill.
Great to
Really
meet you,
appreciate
folks.
it.
Thank you.
You have a wonderful day.
All right.
Thank you.
All right. And we are